All right, so we're on step 3. What we want to do is do a calculation on interest rate sensitivity. I've just here, these are equal from the bonds page. Drag everything across so that I have the relevant information. These numbers here are coming from the port form. Right here, my 74, 28, 16, 53, and 100. My net investment, my target distribution. So what I want to do is, as interest rates go up, and this is plus 1% from where they are when I purchase the bond versus minus 1% from where they are when I purchase the bond. I want to find out what happens to change the value of the portfolio. In other words, how much the portfolio fluctuates. So what we need to do here is find out what the contribution is. So our first step is the negative sign, negative PV of ES, that's the yield to maturity, plus the interest rate deviation. So this would be 1% increase in interest rates. Instead of having a yield of 3.29%, I'd have 4.29%. Divide that by 2, and then the difference in the periods. So that's how much time's left on the bond, times the payment, which is the coupon rate, times the face value divided by 2, comma 1,000, that's the value of the bond, plus the future value of my interest payments. And again, we have our yield plus the deviation divided by 2 times the number of periods, 17. In my case, yours is going to be 9.5 years, so it shouldn't be 17, times the payment divided by 2. So the idea here is that the value of the bond, as interest rates go up, the value of the bond goes down. On the other hand, as interest rates go up, that means the value of the coupon payment moved into the future. It earns more interest and therefore becomes more valuable. And as long as the duration of the portfolio is exactly equal to when you need the money, then the total value of the portfolio should not have much sensitivity to changes in interest rates. And that's what we're looking at here. Okay, so we do that for each one of these bonds. So present value, notice the dollar signs. The only thing that shouldn't be dollar signed is the A9. We want to drag that down. Our numbers here, each one have been dollar signed. They're not changing. If I rebalance a portfolio, I want them to change, but until then, nothing. And then the value of the portfolio is just some product. It's the contribution at the end, in my case 8.5 years in the future, times the number of bonds that I'm purchasing, and that's going to give me the value of the bond. And then one of your requirements is to go ahead and give me relevant information to bond sensitivity and relevant information relative to your constraints that you applied, with a focus on you're presenting this to a customer. So obviously some values, what's the range? So the high value, the low value of my ending portfolio, 1% change in interest rates, the portfolio is only changing by $585, which is relatively small. The average value is 397, the standard deviation is only 180, so on average I'm going to be around $180 from this $397 value. And that's what the whole idea of bond formation and immunizing is taken care of, is that as interest rates change, even substantially, 1% plus or minus is a pretty big move in interest rates, our net position in the portfolio doesn't change. I mean, I don't want to see this. Okay, this is data. I'm not interested in seeing plots and plots of data. If you do include it, expect a lower grade. What I want to see is a plot of the sensitivity. So here I am plotting the value of the portfolio. Here's my changes in interest rate, so 1% increase. This is 0%, that would be my target position, and then decreases in interest rates. And the net change in the portfolio. You can see I'm going from a low of 397,000 to a high of 397,700. So there really isn't much change. And then you should incorporate in your write-up a discussion of this, the overall sensitivity, and I'll let you go from there. All right, so our next step is going to be the duration plot, and that will be another video. Thanks.